First, consistency and stability. At the root, enzymatic fragmentation is picky chemistry. Change the tissue type, GC content, or DNA quality, and the reaction behaves differently. That is why protocols have to be re-optimized every time the project changes. Mechanical shearing is much more agnostic. Once the acoustic field is set, it treats high-quality DNA and FFPE DNA in a very similar way. Most of the time, labs only adjust time and power, not the whole protocol. For your MGI customers, this means that one validated BOFU program can often cover multiple sample types, and once it is set, they can scale up without constantly rewriting SOPs. Second, GC bias. Fragment size is not the only issue. GC bias matters just as much. Mechanical fragmentation creates breaks by random physical forces, so GC-rich and AT-rich regions are treated almost equally. Base composition plots before and after shearing look very similar. The curves stay flat and close together. Enzymes, however, prefer certain sequence motifs. Some GC-rich regions are cut more, others less, which produces bias and uneven coverage. That shows up later as unstable variant calls and missing mutations. So when you promote BOFU, you can highlight that it improves both size control and GC uniformity, which directly supports more reliable panel and WGS performance on MGI instruments. Third, optimization burden and flexibility. Consistency always has a cost. With enzymatic kits, the cost is constant re-optimization. Change DNA concentration, switch to another kit lot, or introduce FFPE blocks, and the whole method has to be tuned again. Mechanical fragmentation removes most of that burden. The shear force does not care whether the DNA concentration is 5 ING-UL or 50 ING-UL, and it is much less affected by fixatives in FFPE. One protocol can often serve research samples and clinical samples with only small parameter tweaks. For lab managers, this means fewer surprises, fewer failed validation runs, and a smoother path when they want to move an MGI assay from research use toward routine diagnostics. Fourth, FFPE performance. Let's look at what happened specifically in FFPE. Discovery Life Sciences compared mechanical and enzymatic fragmentation across multiple FFPE cohorts and measured median insert size. In almost every cohort, the mechanical group kept a longer, healthier insert size, while enzymatic fragmentation shifted DNA towards short, damaged fragments. For exome and large panel sequencing, that extra length means better capture efficiency and fewer libraries that fall below DV200 thresholds. So for MGI customers with heavy FFPE workloads, you can say very directly, mechanical shearing does not just survive FFPE, it actually protects library quality compared with enzymatic kits. The same FFPE study looked at discordant variant calls. Libraries prepared with mechanical fragmentation had much lower discordance across all input levels, even though basic sequencing metrics like Q30 were very similar between groups. In other words, under the same sequencing conditions, the improvement came from cleaner libraries at the fragmentation step. FFPE artifacts disturb enzyme activity and create false variants. Mechanical shearing is largely insensitive to those chemical changes. A simple message for your conversations is, for FFPE on MGI platforms, mechanical fragmentation lowers false positives without sacrificing Q30 or coverage. Fifth, methylation workflows are even stricter. For methylation applications, the rules are even stricter. Bisulfite conversion already damages DNA, and many enzymatic fragmentation modules can erase or modify methylation marks themselves. If that happens, the lab is no longer measuring the original epigenetic pattern. For this reason, major guidelines recommend mechanical shearing for high molecular weight DNA before methyl CQ. Focused ultrasonication platforms like BOFU fall into the safe category. They shear DNA mechanically without using enzymes that could modify or erase the methyl groups researchers are trying to read. This is a strong argument when you talk with epigenetics labs or translational groups planning methylation projects on MGI sequencers. Vendors themselves confirm this. For example, in the EM-Secu workflow, New England Biolabs clearly states that upstream fragmentation should be done either by mechanical shearing or by their own ultrashear reagent. Other enzymatic fragmentation kits are not recommended because they risk altering methylation marks. In practice, this means that methylation labs have only two realistic options: a focused ultrasonicator, such as BOFU, or the dedicated NEB reagent. So for MGI and your distributors, BOFU is not just another choice. It is one of the few validated methods that align with current methylsec best practice. Finally, artifact variants. Another study looked at 54 paired samples where the same DNA was split into two arms, mechanical versus enzymatic fragmentation. When variants were called, the enzymatic arm produced roughly twice as many SNVs and indels per sample. Most of those extra calls were not real mutations, but artifacts created during enzymatic fragmentation. Mechanical shearing kept that background much lower, giving a cleaner variant list. So if your end user is focused on low-frequency mutation detection, for example deep tumor panels or MRD projects on MGI platforms, mechanical fragmentation is the safer starting point. Putting all the evidence together, enzymatic fragmentation and focused ultrasonication are really two different leagues. Enzymatic kits drift from operator to operator. Focused ultrasonication uses fixed physical parameters and stays stable once validated. Enzymes often introduce GC bias. Mechanical shearing gives much more uniform coverage. Enzymes are sensitive to sample type, pH, and solvents. Focused ultrasonication is broadly compatible with fresh tissue, blood, cfDNA, and FFPE. For methylation and rare variant work, mechanical shearing keeps background artifacts low. On top of that, physical methods typically preserve more DNA, so fewer precious samples are lost at the fragmentation step. For your customers, the message is straightforward. If they want robust, reproducible libraries, mechanical fragmentation should be the foundation, and BoFu is a practical way to bring focused ultrasonication into their daily workflows on MGI platforms. To close the fragmentation chapter, we can look at mechanical shearing from three angles that matter to lab managers and to your distributors. Ease of use. One validated protocol works across many sample types. BoFu instruments are standalone, touchscreen-driven, and easy to train on. Performance. Libraries show high pass rates, lower duplication, and minimal GC bias, which all translate into more reproducible data. Economics. When libraries pass on the first attempt and coverage is more even, labs use each MGI flow cell more efficiently and repeat fewer runs. The cost per reportable sample goes down. So mechanical fragmentation is not only a technical improvement, it is a business improvement for any lab that wants to scale NGS on MGI systems.